Hello. So today in this new episode, we're going to talk about some other functions in PyTorch, and especially it's in the neural network. Okay, so and those functions, including the sequential and linear, relu and module. So some of those are some pretty specific functional things, but some others, such as this module, this is pretty general. Okay, so we're going to use this module to define our own networks. Okay, including we can easily define something like the n sequential, or we can simply make some combinations such as linear or relu, or we can even add some loops or some computations inside of our own modules, our own networks. Okay, this is very important, right? So because whenever we are writing some codes, or we are designing some architectures, we have to be able to design our own sort of the block or the module, right, for the networks. Okay, good. So let's begin with some pretty basic stuffs. So let's see, we're gonna have this x. Okay, so this is a tensor. Okay, so recall that what we have discussed previously. So we have 3 dimensions. Okay, so those are the sizes of those three dimensions, and this 2 is going to be the shape or the size for the most outside dimension, right? So the 4 is going to be the most inside one. Okay, so this is just a tensor, right? So, and remember that something very important is that, okay, so we have the note here. So no matter how many dimensions we're going to have, so those operations, okay, so it's not only this linear. So a lot of operations they only operate on the most inside dimension. Okay, so those most inside dimensions are often called features, right? So that means although we're going to have maybe even more than 3 dimensions, we're going to have a lot of dimensions, it doesn't matter. Okay, so you don't need to worry about that. You don't need to worry about anything before the last dimension. So all those operations they're gonna simply work or operate on the last dimension. Okay, so this is something very important. So, and you can even, so let's just have a quick look on this. Okay, let's say we have this. Okay, so this x is something like this. Okay, so that, what do I mean by this operation on the most inside dimension? That is, we have this as the most inside dimension, right? Those, so on and so forth. So whenever we are having some neural networks, we're going to have some linear functions, or some relu, or some other activation functions. We're going to always operating on those things. Okay, so, and repeat again on those things. So you can't just regard this tensor as some like multidimensional matrix, right? And those very basic vectors on each most inside dimension are the things that we call as the features, right? So those would be the things that are the basic dimension that we're gonna be working on. Okay, good. So let's continue our example and see how it works. Okay, so we're gonna have our first example here, that is this nn linear. Okay, so basically, if you can have a look on the mathematics of this, right? So basically, we're just in the neural network, we're just doing the matrix multiplications, right? So you're gonna match the dimension. So the reason that I mentioned this, okay, this is simply because we have to match this dimension. This is the dimension for the input, and this is the dimension for this linear output. So we have to match the input dimension to the most inside dimension of this input tensor, right? So that's what I mean by this this part. Okay, so that's something very important. If you don't match, then there's going to be some error. Okay. All right. So this is a linear function. Okay. So and we could have a look on this part. Okay. So let's put it here. Okay, so this is simply basically it, right? So you can see from here, we didn't change those two dimensions, right? So those two dimensions are 2 and 3, right? We have 2 here, and we still have 2, and 3 brackets, we still have 3, right? The only thing that has been changed, that'll be the most inside dimension, right? So we simply multiplied those most inside dimension with the other matrix, right? With this dimension of 4 and 10, and then previously we have this 4, and we multiplied by this 4 and 10, so that's gonna be the new output dimension. That's gonna be 10, right? And while we still keep those two dimensions, those are not changed, right? So that means previously we have 4 numbers, so after this linear we're gonna have 10 numbers. Okay, so that's it, right? And 4 here, 4, 10 here, 4 here, 10 here, right? That's it. That'll be this linear function. Good. And I hope that this could be useful. Okay, so now let's continue our discussion. So that was linear. Okay, well, that linear is pretty basic stuff, basic block or function in the neural networks, right? And we also have some activations, okay, such as maybe relu or sigmoid, something like that. So this relu, we do not need to specify the dimensions, because those activations are just one-to-one map, right? So we don't need to care about the dimensions here. Let's have a look on this relu function. Okay. So okay, let's see, that should be here. Okay. Okay, so right, so this so if you know the math of relu, that's going to be, we will have, if the number is greater than 0, then we're going to have the same number as the input. If that's less than 0, we're going to put that as 0, right? So let's print this X as well, and maybe comment this. Let's print this. Okay, so let's compare something before and after the relu. Okay, so you can see that, right? So if this thing is bigger than 0, and that still gives us the same thing, but if that number is less than 0, then we're going to output 0. So that's the meaning of relu, right? So you can have a look on this definition of relu function, but it's essentially that simply map one-to-one, right? That'll be a one-to-one map. This maps to this, this maps to this. So we don't need to specify any dimension. Okay, good. So then now we know this relu. So the next thing, we can make a chain, okay, and we can connect, and we can link those functions, and that's called sequential. And this is written in nn. Later we can even define our own sequential function, okay, using the module. But here we're gonna just have a brief look of this sequential function. Okay, so that's just some function that help us to put all of those in a chain or in order. Okay, so this is a list with order. Okay, so that means we're gonna have this. Let's call this as some long net. So we're gonna first have some input. Okay, and that is multiplied by this matrix. Okay, and then that goes through this relu, and then we're gonna also multiply by this. Okay, remember that we're gonna have this 512, and this still outputs 512, and then the output of 512, that has to be the same as this input of 512. Okay, So that's important. and in the end, you can specify how many dimensions you're gonna, how many what's the size of the dimension that you want, right? So for example, if you want to have a binary classification, you're gonna have 2, or if you want to have maybe a classification of the digital numbers, you're gonna have 10, right? So, and that we can talk about that later. Maybe we're gonna need maybe something else, right? Like softmax or something else, some other functions. But okay, that'll be something later. Okay, so now we know how those dimensions work, right? And how those functions work. Okay, so let's print this sequential and have a look. So this Z, this guy, that's gonna be, let's okay, so that's it. So we simply put this, okay, we should have this, right? Okay, so we put this, let's see, we put this X, okay? So X is our input for this long net, and X was 234. Okay, so now it's 23512, 23512, and 235. Okay, so let's have a look on this net. So that has to be 235, right? So 5 numbers here, and 3 here, and 2 here. Okay, good. Okay, so that was pretty much for the sequential. Okay, so next we're gonna talk about this nn.Module. Okay, so this nn.Module, that is pretty powerful, and basically all of those things are just defined, or they all inherit some features from this module. Okay, so this module that allows a lot of flexibilities for us to design our own networks. Okay, so let's have a look on this module, this class. Okay, so basically we're gonna every time if we need to define something, then we have to define a class, right? So based on this module. Okay, so let's try to define this class. So we call this class as a multi-layer perceptual MLP, and that is having the same all of those features, right, contained from this module. So this is like sort of the inherited from this class and module, right? So, and then we're gonna define. So we're gonna first we have to init, right? We have to initialize this this class, and here we have a node. We can put a lot of things here, okay, and such as our pretty fundamental network structures. Okay, later we'll see. So here we can already see this, right? So we can define our something called hidden or some out, right? So we can even specify those dimensions or some functions, right? We can put all of those here and then call them later, right? So here something important to notice is that we also need to put this thing here, right? So this is some function from Python, and this is useful for us to simply to inherit or to keep or to retrieve all of those functions written in module, right? So that will be able for us to use those things in the old class, okay, to help us define our new class. Okay, so and then we can define our self.hidden. You can give this some other name if you like, and this is going to be the nn linear width. But we have to pay attention to those dimensions, right? Always. So this is going to be an input with 10 and output for 256, and then we're going to call some out as a linear of 256 and 2. Okay, and then we will need to define. So those two are the necessary parts that we have to define for a class from module. Okay, so the first thing is this init, and the second thing that is also necessary, that will be this forward. Okay, So this forward, that simply should contain those information that we need for our flow or our forward computations, or the forward flow of this network. Okay, so and you can write this as just as a return, and you can nest all of those together. But alternatively, you could just write those explicitly, right, as some functions. We can see that later. So here we simply have some self.out. Then we're gonna use this this relu from the functional of and we're gonna have this hidden for first, okay, for the x, for the input. Okay, and we have to initialize this. We have to make an instance for this class, right? So this is gonna be our MLP, and let's put this x and have a look at this output. Okay. All right. So here's our input, right? So our tensor looks like a tensor with dimension of, so that's going to be 2 by 10, right? So, and after that, let's have a look on those things that have been done in this network. So let's have a look here. So the first, that's going to be this hidden, right? So hidden, that'll be 2 by 10 multiplied by 10 by 256. That's going to be 2 by 256, right? And after relu, and it doesn't change the dimensions. And then after this, up to the out, right? So this, so finally it has to be a 2 by 2 matrix, or 2 by 2 tensor. Okay, so that's it. Good. So you can see that this module, this is pretty powerful and very helpful for us to define our own network structures, right? Good. So next, let's try to make our own nn.Sequential. Okay, so this should be in capital letter. Okay, so in this nn.Sequential function, that's simply, this is also a sort of a module, right? So we're gonna also use that module to define this sequential function. Okay, so let's say we define this class called the new sequential, and we do the same thing again, but here we have something different. Okay, this is also a feature in Python, and if we put this sort of star args, and this args here, this simply means that that'll be sort of a ordered list. Okay, this is an ordered list of inputs. Okay, so and then we can pass this ordered list of inputs to this function. Okay, to whatever that you need. Okay, so then we can parse this, right? So we for this each item for the net block inside of those args, okay, we're gonna simply have, so this is also something in this module. Okay, we're gonna simply to identify, right, those those net blocks. Okay, we simply retrieve those. So this is ordered dictionary, right? So instead, so we're gonna retrieve all of those, and we simply put the net block as the value, right? So this is gonna be a dictionary, right? So we from this list, and then we save this as a dictionary. Okay, so and we have this net block as its value. So and this simply helps us to parse all of those args, right, as we mentioned. So that's it. And then we also need to define this forward function, right? Remember, this is also necessary in a module class. So then we're gonna define for each item in this, right? So in the self dot underscore modules and values, right? So we're gonna iterate for all of those values. Then we're gonna simply so this is our input, right? So we're gonna have this input, and we're gonna have simply to retrieve all of those values, right, from this each item, right, and use this as our key, right? Okay, and then this returns this x. Okay, so that's it. Okay, so that would give us this those blocks, right? So that puts all of those blocks together, which has this input, right? So, and let's have a look on this example. So we're gonna let this net to be this new sequential, and that takes, like we said, this would be an ordered list, right? So that gives us this. So we're gonna put those. The first is linear, and then we're gonna put a relu and then linear. Okay, and let's have a look on this example. Okay, so the x still this is a 2x10 tensor. Okay, so the first that goes through this linear, so that becomes 2x512 and the same dimension, and after this that's gonna be 2x2, right? So this would be essentially the same thing as we did if we use a dot sequential, but here instead of that we have defined this our own new sequential function, right? Or this would be a class instead, right? So to achieve the same functional purpose as we did in the nn sequential, right? Okay, good. So the last thing that we're gonna talk about today, so we're gonna use this module. Okay, so this is pretty powerful, and we can also use that to further to try to change something inside of init and inside of forward. You can even add a lot of other things, and even maybe try to do our own matrix multiplications, and maybe we could even fix some weights and to make those weights not being updated for when we're training the model, right, later. And even we can do a lot of things. So let's have a look and at this, how we're gonna do this. Okay, so let's call this class that we're going to define as this fixed hidden net. So let's do some module. Okay, so, and again we do the same thing as before. So let's first define some so-called fixed weights. Okay, so this would be a random tensor with 512 by 512. So we're gonna say that this doesn't require any gradient. Okay, so that means those weights. Okay, so this tensor that doesn't attend the back propagation of the arrows, and then we don't have any gradients for them. Okay, so that's simply the meaning of this. Okay, sometimes we might need this, right? And later we're gonna see how we're gonna use this, and this is simply just example that to show what else we can do here, right, inside of this init for some module class. Okay, and then we're going to define two different linears. Let's call this linear 2.512 as this, and 5.12 as this. Okay, so just make the difference. Okay, so and then we're going to define our forward function. So this would be, first let's put this x into, so x that was 2x2. Okay, now this would be different x. So this x 2x2, and then this would be 2x2 multiplied by 2x412. That's gonna be 2x412, right? So next, then we say that we're gonna have some. Okay, later we're gonna have some relu. Before that, so let's first take a matrix multiplication. Okay, so and then we're gonna multiply those two matrices or those two tensors. So the first, that'll be this x. Okay, so this is already 2 by 512, right? And this fixed weights as we defined, so this is 512 by 512. Okay, so this is gonna output a matrix of 2 by 512. Okay, and then we're gonna simply, let's say, plus 0.5. Okay, we just want to do this. Okay, and then let's put this into the relu. Okay, so finally let's use the second linear we just defined, and to make this x to let it go through this linear. Okay, and finally, if we are correct, that should be something in something in the dimension of 2 by 4 and 2, right? If I'm correct. Okay, you can check this, right? So, and then we can even write some loop here. Okay, so this is just to show that the things that we can do. Okay, and so we can say that we're gonna take the absolute value of the x, and we're gonna simply sum all of those elements in x. Okay, so if this is greater than 1, we're gonna simply divide this x by 2. Okay, and then finally we're gonna return some scalar. Okay, we're gonna just sum all of those again for this x and return that. Okay, so that's gonna be some scalar eventually. Okay, so let's have a look on this now. Okay, so as we just guessed, so this tensor that's gonna be simply with a 0 dimension, right? So this is gonna be simply a scalar. Okay, so and this is our x, right? So you can see that this using this nn module, we can do a lot of things actually, right? We can define the we can even define a lot of those functions that we use. For example, the n sequential, right? Using this nn module. So we can see that this nn module is pretty powerful and very general, right? And that includes a lot of those things here. Okay, so and yeah, so that'll be everything for this episode.